This section is 9.1. It's about translating figures. It's one of our types of transformations. The transformations that we're going to study consist of translations, which is just moving an object, reflections, which is reflecting an object over a particular line, rotations, rotating an object around a specific point, a certain amount of degrees, and also dilations. Dilations are the only ones that will actually change the size of the figure. The others will keep the figure the same exact size. The angles will remain the same. But with a dilation, the angles will remain the same, but the sides will either increase or decrease depending on the scale factor. So those are the things that we're going to study in this part of this unit. So this is about translating right here. And there's two ways that they can tell you how to do a translation. They can use a rule or they can use a vector to tell you. This right here, this is a rule. The way they wrote this, they wrote x comma y with this arrow, which usually is like such that x minus 5 and y plus 8, which means they want you to take the x value of the point and subtract 5, which would move it to the left 5. And they want you to take the y value from the point and move it up 8. So the y value is going to increase, moving it upwards. Remember that the x, if they add it, would go to the right, subtracting to the left, and with the y, adding up and subtracting down. So with these, we're not graphing it, we're just using a point value. And I want you to notice that the two on the left, they ask you for the image. The image is the new one. And you write the image with a prime marking. So like B prime would be the new one. The old one is B, the new one's B prime. So the old point was 4, 2. So for the x, which is 4, we're going to subtract 5. 4 minus 5 would be at negative 1. And then for the y, 2, they want us to add 8. 2 and 8 is 10. So that'll be at negative 1, 10. Over here, they want us to do something different. They want to know what is the pre-image. So a pre-image is like we have to go back in time. They've already done this change. And so we have to figure out what it was before the change. So the change that has happened is they have subtracted 5 from the x. So we want to go back in time and do the opposite. We want to add 5 to the x because look at it has this f prime. This was the new one. We want the old one. So what we need to do is take this x value of negative 3 and we need to do the opposite operation. Add 5 to it. If we add 5, we'll be at 2. And this would also be the point called f because this is f prime. And then the negative 4, we have already added 8 to that. So we need to subtract 8 from the negative 4, which will put us at negative 12. And then if you want to check your answer, take this as the original and do what it says. 2 minus 5 is negative 3. Negative 12 plus 8 is negative 4. So we've used the rule to check it as well. For number 3, they want the image, they want the new one. D prime, just use the rule like normal. Negative 1 minus 5 is negative 6. 5 plus 8 would be at 13. And then this is a pre-image one again. So the pre-image going back in time. This is H prime, we want to go to H. It's at 7. We need to add 5 to go the opposite. So adding 5 to 7 is 12. And negative 5 minus the 8, negative 13. And that would be the pre-image. So you always want to watch out. Do they want the image? Do they want the pre-image? It's really important to know which one is which. On the bottom of this page, they are asking us to write a matrix to represent a point or a polygon. They're not asking us to do anything to it, but just to how do we use a matrix to represent it. And we are going to be using matrices to represent figures because, in my opinion, It's easier to apply a rule to a matrix than it is to apply a rule to an individual point and then do that over and over. So I am going to expect you to be using matrices. Sometimes I'll give you a question in the form of a matrix and you just have to be comfortable with it. All we're doing really though is using them to represent the figure. We're not going to do a lot of math with the matrix itself. So what you do with a matrix for point A, you're going to put the x on top and then the y underneath it. So for point A, we want our x value and then our y value. So I'm going to label point A. It is at -3, 0. The x value is -3, the y value is 0, and that's the answer. That's the matrix to represent point A. If we want quadrilateral ABCD, then we want A, B, C, and D. Again, remember the x is the top, the y on the bottom. So I'm going to go and label my points, though, before I do anything. B is at 0, 1, 2, 3. C is at 2, 1. And D is at -1, -1. So I just need to fill these in. A is at -3, 0. B is at 0, 3. C is at 2, 1. And D is at -1, -1. So now this is the matrix to represent quadrilateral ABCD. It's just an organizer of your points. That's all I want you to think of it as, but we are going to be using them.